All right, so we're going to talk about equilateral and isosceles triangles. So a triangle is isosceles when it has at least two congruent sides. When an isosceles triangle has exactly two congruent sides, these two sides are the legs, and the angle formed by the legs is the vertex angle. Sorry, I've added a few words there. The third side is the base of the isosceles triangle. The two angles adjacent to the base are called base angles. So I did give you that picture right there. Okay. So our vertex angle is this one right here. And then these two here are our base angles, and they're pretty important. And again, the legs are opposite, and the base is always opposite the vertex angle. So a couple more theorems here for you. If two sides of a triangle are congruent, then the angles opposite them are congruent. So what that is saying is if AB line segment is congruent to line segment AC, then we can say in this case, since they're not attached to anything else, we can call these two angles by just the one letter, and we can say that angle B is congruent to angle C. That's the base angles theorem. All right, so it says the base angles theorem. So the next one is the base angles theorem converse, which tells us, again, they just switch the if and the then part, if you want to think about it that way. That's what a converse does. So on this one here, it changes the then to the if. So what it is saying then is if two angles of a triangle are congruent, so if, look at the above one, if angle B is congruent to angle C, then the sides opposite them are congruent. So the sides opposite them are these ones right here. And again, I just told you we switched the if and the then on theorem 5.6. So then we can say then line segment AB is congruent to line segment AC. That's what those are. So again, some pretty simple examples for you today. Example one, in the figure, angle A is congruent to angle B. So that's something we already know, right? And then it says name two congruent sides. So which one are we going to use? The base angles theorem or the base angles converse? So they've told us that angle A and angle B are congruent. So then we know the sides opposite those. So that would be this side here and this side here. All right, remember, one way to remember when a side is opposite an angle, I can draw an arrow and it will go to the opposite side. That's going to be important for us when we start talking about sine, cosine, and tangent clear in chapter 9. So knowing that, ladies and gentlemen, what did I just tell you? So name the two congruent sides. Well, we can say then that AC, line segment AC, not AB, AC is congruent to line segment BC. All right, remember corollaries are things that we assume to be true based on a theorem. So corollary 5.2, if a triangle is equilateral, then it's equiangular. And then the converse of that, if a triangle is equiangular, then it is equilateral. All right, so that can help us out when we're trying to find certain things. So on this one here, it says find the value of x. So if we look here, we see that they gave us all three sides. So we know that it is equilateral. And if we know it's equilateral, we know it is equiangular. All right, so if we know that, then we know that all three of these angles, okay, now without the x there, but we know that all three of them, we know that 3 times those angles is equal to 180. So we know that angle R, so that leads us to know that angle R is equal to 60, right? So the measure of angle R is equal to 60 degrees. But according to what we have here, we know that angle R is equal to 2x. So we know that 2x is equal to 60 degrees. So again, if we divide both sides by 2, we get that x is equal to 30 degrees. All right. And then our last two examples, find the values of x and y. So let's see, what do we know? Let's see, we know that this, again, remember the other day I told you, well, today actually, so I told you, mark what you know, all right? So we know that this one here is equal to this one here, right? We know that all three of those for that triangle right there are equiangular. So we know that each one of these is equilateral. So if that is equilateral, we know that this length here is 28 and this length here is 28. So look, we can solve for y already, because we know that 4 times y is equal to 28, right? And then if I divide by 4, I know that y is equal to 7. All right? So now we know that this angle here is different than this angle here. So why don't I use a different color for you? Okay. So let's see. We know that that angle is, and we already know what it is, right? We know that this one here is 60 degrees. So we know that this one has to be 120 degrees. And again, why? And you're going to tell me because it's a linear pair, Mr. Baumeister, and a linear pair is always 180 degrees. Right? Now, look at this here. This angle here, I mean, that side there is 28, and that side there is 28. So we know that this is an isosceles triangle, right? So if this is an isosceles triangle, we know that this angle here and this angle here are the base angles for this triangle right here. All right. So if this one here is 20 degrees, 120 degrees, excuse me, then we know that each one of these has to be what? Well, the angles of a triangle add up to 180. So we know that both of those together is 60. So we know that each one of them, because the base angles are equal in measure, we know that each one of them has to be 30 degrees. All right. If they both have to equal 30 degrees, then we can say that 2x is equal to 30. Again, divide by 2, and we'll get that x is equal to 15. So again, just think, ladies and gentlemen, we don't always have to solve for x first. All right. Hopefully you saw that we could look at the sides first on the equilateral triangle. All right, so let's see here on these ones here. So on part B, our last one. So with this angle here and let's use a different color this time. This angle here is 40, all right? We know that this side and this side are the same length. It's different than this side right here. So we know that each one of these, their total, because it's 140, because they have to equal 180. So we know that this angle here is x degrees, and so we know that that angle there also has to be x degrees. So if that's the case, then we know that x is 140 divided by 2, because they're the same measure, so we know that it has to equal 70 degrees. All right? So now that will help us, because again, for the next triangle, let's see here. Why don't I go with this color here? All right, we know that this is an equilateral. So we know that all of these are the same length. So since we know that they are all the same length, we know that we can say that 2y plus 10 is equal to x minus y. Okay? From above, now remember, this time I had to solve for x first because I have to use it in the second equation. So from above, we know that 2y plus 10 is equal to, well, our x is equal to 70 minus y. Now I just have to solve for y. So I'm going to bring this negative y over to the other side of the equal sign. So 2y plus y is 3y. I'm going to take this 10. Now notice I'm doing it all in one step here for you, but again, I'm using my brain. So I have a plus 10 on this side. When I move it over to the other side of the equal sign, it's going to be minus 10, and 70 minus 10 is equal to 60. Now again, to get y by itself, I'm going to divide by 3, and I'll get that y is equal to 20. All right, we're getting some pretty easy ones done here, ladies and gentlemen, just in time for Parent-Teacher Conference.